This is question number 11 from the 4.5 MyLab math homework about absolute extrema. And in this problem, we're given some clues, and then we're being asked to figure out whether there's an absolute extrema based on these clues. So here are our three clues. The first one is just a point on a graph. Now, we don't know the function, we don't know the rules, so I can't actually input an 8 into the function. So I'm just going to draw it abstractly here. So here's my x-axis. It's a graph of the function, so I'm labeling my y-axis as f of x. And if x was equal to 8, I have no idea where this point would be, but it would, I'd plot the point somewhere along this vertical line. As long as the point lines up with the input x equals 8, that's fine, because this is just an abstract idea here. So this point would be input being 8, and the output is whatever I get if I could actually plug 8 into the function and calculate that. Okay, so I just arbitrarily put the point there, but then it gives me some other clues. The next clue is that the derivative of the function when x equals 8 is 0. Okay, so it tells me the derivative at x equals 8 is 0. That means there's a horizontal tangent line at x equals 8. So I'm going to sketch out a horizontal tangent line there. So if I put 8 into the derivative of the function, it would come out to be 0. Then the third clue it gives me is that if I put 8 into the second derivative, it would be greater than 0. So if I put 8 into the second derivative, it's greater than 0. Greater than 0 means it's a positive output. So think about a sign chart for second derivative. If I do a test point, so think about x equals 8 being my test point. If I did a test point on my second derivative sign chart and I got a positive output, that would mean my graph was concave up at that point. So I know my graph is going to be concave up when x equals 8. So if these are all the conditions, then I know I have a local minimum there. It may or may not be the absolute. I'm not sure yet. I don't have enough information, but I know this is going to be a local minimum at x equals 8. I don't know what the actual minimum value is. I'd have to be able to plug 8 back into the original function and follow the rule and see what the output is, but I know it's happening when x is equal to 8. So that would be answer choice A on this one. Okay, now if it happened to be that this local minimum was the only extrema over a certain interval, then it would be the absolute minimum, but I don't know that for sure. All I know right now is that it's a local minimum.